Well, in this video, I'm going to be solving this question from circular motion. It's a case of a body that moves with a constant speed in a horizontal circle. A particle moves with a constant speed in a circular path. The question says, what is the ratio of the average velocity of this particle to its instantaneous velocity when the particle must have described an angle that is equal to theta over 2 pi over 2 radians. Sorry. Now, let me quickly say this. Start by drawing um, a circle representing the path the body is moving in. And the parameters of this question, displacement, angular velocity, and all that, I've already explained that in my previous video. So if you haven't finding it difficult to follow, I'll refer to my first two videos on circular motion. Okay, let's say that's a particle moving in this path. That's a certain time t is equal to 0 or thereabout. The particle is at point A, and this is the radius of the arc or the track. Now, after some time t, some seconds later, or thereabout, it moves to a point B, okay? And the distance, angular displacement covered is this theta measured in radian, and we're given as pi over 2 radian. All right. Now we have to find the ratio. What is this instantaneous velocity? Of course, it's the velocity of the particle at a given instant. And since the velocity is constant, we can take the instantaneous velocity as the same because it's constant in magnitude. So let's call that v. And at point B, the value of the instantaneous velocity still remains v. And then the average velocity, let me define this symbol, v AV, that's the symbol of my average velocity. It is defined as the total displacement of the particle. Total displacement of the particle divided by the total time taken. Okay. Now, let me first of all start by writing the expression for the total time. Total time taken will be given by, of course, from this equation, angular velocity is angular displacement divided by time t. Okay. Now, so that time t will now be equal to angular displacement divided by angular what? Velocity. Now, what is this my theta? It is pi over 2 radian. Okay? And then what is my angular velocity? We know that angular velocity is angular speed, which is also our instantaneous speed. Sorry, it is linear speed divided by the radius of the path. Okay, so I'm going to replace that here. This is going to be equal to what? V divided by R, and this R goes up. Okay, that gives me pi R divided by 2 times V. So that's the expression for the time. Okay, now let's come back to look at the total displacement. The total displacement is not the same as the distance because the distance covered as it goes from A to B is the length of this arc. Arc length is the total distance covered by the particle. Now, the displacement is just a straight line that joins the initial position of the particle, which is point A, to its final position. So the length of this line AB is the particle's displacement. You know, displacement is always said to be the shortest distance between 2 points. That straight line that joins 2 points is the displacement, whereas distance is the length of path. So it doesn't matter if the particle were to follow a path that is not straight. The total distance covered is the length, that is the length of that path. That gives the total distance covered by the particle. Okay, so given that this our angular displacement is pi over 2, of course in degrees, pi over 2 is in radian, but in degrees is 90 degrees. Of course, you know that 360 degrees equals 2 pi radian. If you already know that, that is it. If you don't know that, that is what it is. And so that pi radian is 180 degrees. So that if you divide further by 2, both sides by 2, you come to see that 90 degrees is pi over 2 radian. Okay, so which means this is a right angle triangle because one of the angles, the angle subtended at the center is 90 degrees. It's a right angled triangle. And we can use Pythagoras theorem. And recall that this is the radius. We call that R. This line is also, let me call the center O. This and that radius R. So that means that by Pythagoras, my AB, which is my displacement, I call that AB squared, is equal to R squared plus R squared by Pythagoras. So that my AB is equal to the square root of 2R squared. So my AB is equal to r times what? Square root of 2 multiplied by r, because square root of r squared is r. Okay, so this is my displacement, or I can call that total displacement. Come back to the average velocity equation. It is given by total displacement, which is square root of 2 times r over total time taken, which is pi r divided by 2v. Okay, now, okay, from here, that was our total time taken. Now some terms will cancel out. And what is that term? If I'm not missing out anything, this cancels out this. And then I'll have my 2v multiplied by root 2 divided by pi. Okay, that gives me my average velocity. But the question asks to find the ratio of the, what is that again? Average velocity to the instantaneous velocity. That's the ratio. So my average velocity, V average over V instantaneous, that is the ratio. Okay, that will be given by what? 2V root 2 divided by pi times this V. Now this velocity here is the same thing as the V here. So this will cancel this V. So the ratio becomes 2 root 2 divided by pi. So that gives the ratio, no units. Ratio, the two units will cancel out of the average velocity to the instantaneous velocity. We will take another question in the next video.